look at Unit 4 Worksheet 3, color coding while charging a capacitor. Before we get too far into this, I want to remind people that we have previously determined that we were going to use colors to represent pressures, red being the highest pressure, orange for high pressure, yellow for normal pressure, green low pressure, and the lowest pressure would be represented by the color blue. So we start here with a charging loop that does not have a battery pack inserted yet. And if you read the reading down here below, it's before the battery pack is there, so there's no battery pack, and so we have an original normal amount of pressure, which all that means is that there's a normal concentration of charge, just like if you picked up a wire off the table. And we're going to represent that normal amount of pressure with the color yellow. So we're going to color the wires and the plates of the capacitor yellow. So right now we have yellow and yellow on the plates of the capacitor, which means there's no color difference and therefore no pressure difference across these capacitor plates. Next up, you can read it in paragraph 2, that it asks us to have put in the battery. And in the directions, we're supposed to be coloring the battery terminals, the wires, and the capacitor plates, but not the bulbs. So when we put the battery pack in here, the positive terminal of the battery keeps a high electric pressure. So whenever you have a positive terminal of a battery, you want to color that red. And any wire connected to a positive terminal is immediately going to be red because a wire has little to no resistance. So instantly we reach the highest amount of pressure here. Now, because not a significant amount of charge has gone through the bulb yet, we're going to assume that the concentration of charge in the top plate of the capacitor and this top wire up here is still at the normal pressure. Because there's a color difference, or more importantly a pressure difference across this bulb, red to yellow, that charge is going to get pushed through that bulb and the bulbs will light. Now, just like that's happening on the top part of the loop, the bottom part of the loop, the negative terminal, is at the lowest possible pressure because it has a low concentration of charge. Because a wire has little to no resistance, the wire connected to the negative terminal is also going to be blue. But like we had on the top part, the bottom plate of the capacitor, we haven't lost a significant amount of charge, so the concentration of charge here will be much like it was at the beginning, and so we will say that there's not been a big change in pressure here. But because we have a color difference, yellow to blue, tells us that there's a pressure difference across that bulb, so charge flows to the bulb, lighting the bulb. Now, which of these two pressure differences is bigger? Well, let's take a look. We have red to yellow here and yellow to blue here. We know that charge always moves from areas of higher electric pressure to areas of lower electric pressure, but which bulb should be brighter? Well, from red to yellow, it is a 1-2 step pressure difference, so it's 2 steps, but yellow to blue is a 1-2 step pressure difference as well. Because the difference in pressure from red to yellow and yellow to blue are both 2-step pressure differences, that we're going to have equal flow rate and the bulbs will be equally bright. But as we continue to have charge move from the left to the right through this bulb, we're going to increase the concentration of charge on this top plate, which is going to increase the pressure. And that takes us to figure C. As we stated on the other side, positive terminal always maintains the highest concentration of charge, and any wire connected to the positive terminal will be at the same highest pressure as the positive terminal. The negative terminal of the battery is at the lowest concentration of charge and therefore the lowest electric pressure. But as we said just before, as charge continues to go from the positive terminal towards the top plate, the pressure is going to increase. So what pressure is just a little bit higher than yellow? And that's orange. So we're going to go ahead and choose orange for the color of this top wire and the top plate of the capacitor. Now, just as charge was being added to the top plate up here, on the bottom part of the loop, charge was leaving the bottom plate of the capacitor going towards the negative terminal. This wire had been yellow, but because charge is leaving, the concentration of charge drops and the pressure drops. So what pressure is a little less than yellow? And that would be green. So the bottom plate of the capacitor is now at a low electric pressure, as is the corresponding wire. Because we have a red to orange pressure difference across the top bulb, charge will continue to flow, but not as high of a rate, which is why the bulbs have become less bright. Likewise, on the bottom, we have a green to blue pressure color difference, which is a one-step pressure difference as well. So these two are going to be equally bright. But notice that the red to yellow from the previous one allowed for brighter bulbs. Because it's a smaller pressure difference, the bulbs are less light. Green to blue, a one-step pressure difference. It's a smaller pressure difference, so the bulb becomes less bright. As charging continues, more and more charge gets added to the top plate of the capacitor until charging is completed. When is charging complete? Well, as previously stated, we knew that the positive terminal is red, representing the highest possible pressure, and the negative terminal is blue, representing the lowest possible pressure. But when does charging stop? When we look at the top part of the loop, charge stops when the top plate of the capacitor reaches the same highest concentration of charge or same highest electric pressure as the positive terminal of the battery. Likewise, on the bottom part of our loop, charge will stop flowing when the bottom plate of the capacitor reaches the same lowest pressure as the negative terminal of the battery. Notice there's no longer a color difference across the battery, across the bulb, and therefore no pressure difference, so no charge flows. And on the bottom, there's no color difference across the bulb and therefore no pressure difference. I'm going to thicken these lines out because just to make it consistent. And I hope that helps.